The ionic compound I have is magnesium carbonate, and the formula for it is shown right here, MgCO3. And then right below here is like the Lewis structure that we would draw for this compound. And to draw this, we would start by identifying the different valence electrons in each atom. And so we find that carbon has 4 and oxygen has 6 each, making a total of 22 valence electrons. And then we would arrange the atoms in a way that allows us to form bonds while still following the octet rule. So for here I have a double bond with still 4 on the outer shell, and here single bonds with 6 around each. And also the shape for this is a trigonal planar shape. And to assess the formal charges, we have to compare the number of valence electrons to each atom. We have to compare the number of valence electrons each atom brings to the compound with the number of electrons it has in the Lewis structure. So we would find that carbon has 4 valence electrons, so there should be 4 in its structure, giving it, actually this wouldn't be +1, this would be 0 because there's none available. And then we can see for each of the other ones that there would be a -1 formal charge because of the lone pairs of electrons, because each oxygen has 6 valence electrons, and so then it should have 6 in each one. To draw a resonance form, we can kind of just switch up the drawing in just a little way by eliminating one of the double bonds of one and then just adding a triple bond instead, and making it have less on the outer shell. This really isn't much different, and they're equally valid because they both follow the octet rule for each atom and have the same total number of electrons. And then lastly, the Lewis structure for magnesium would just look like this because it is the cation in the answer, and the natural charge for this would be 0, and basically they would be like net 0 because there are 2 magnesium ions and then 1 of the carbonate ions, and so the overall charge would be 0, and this would be because you would have 2 of each with a charge of +2 and 1 of a charge of -2. So the total charge of cations is +4 is equal to the opposite of the total charge of the anions, which is -4. So it would give you a 0 net charge, and that's it.